What's going on, everybody? Another video here. This video is applications of the indefinite integral. This video is going to deal with the acceleration, velocity, and displacement. So let's go ahead and get started. All right. So let's look at this. If we have the acceleration function, we can integrate the acceleration function, and that will give us velocity. And if we integrate the velocity function, that's going to give us displacement. If you remember from earlier videos or earlier in your course, that if you have the displacement function, if you take the derivative of that, that gives you the velocity, and then the derivative of the velocity gives you the acceleration. We're basically going backwards. We're finding the antiderivative of acceleration to get velocity, antiderivative of velocity to get displacement. And this just tells you what A, B, and S are: acceleration, velocity, and displacement. All right, so let's look at this. It says for an object falling under the influence of gravity, the acceleration due to gravity is essentially constant. Its value is negative 32 feet per second squared. The negative sign is chosen so that all quantities directed up are positive and all quantities directed down are negative. And also, you know that if you were in meters and seconds, this would be, instead of the 32, it would be 9.8 meters per second squared. All right. All right, so let's look at some examples. It says find the equation of the velocity if A, which is the acceleration, is 12t, given that the velocity is 8 when the time at time t equals 1. Now, they don't give us any units here, but we're just, it can be seconds, hours, whatever. Well, seconds. All right, so we've got the acceleration. Let me change colors. We've got the acceleration is 12t. So that means the velocity is equal to the integral of 12t dt. Okay, so if this is the acceleration, if we integrate it, that gives us the velocity. So we get velocity is equal to 6t squared. Remember, you add 1 to the exponent, divide by the exponent, which gives you this, and that's plus c, plus some constant c. Now, what is this information here doing? Well, this is telling us we can plug 1 in for t, and when t is 1, then the velocity v is 8. And what that's going to do, that's going to allow us to solve for c. So if we find v of 1, that's going to equal 6 times 1 squared plus c, and that should equal 8. And so you can see that gives us 6 plus c equals 8. See, that gives us a nice little equation we can solve for c. And so we get c is equal to 2. And so that tells us that our velocity function is 6t squared plus, and then we take the 2 and plug it in for c. And this would be your answer here. All right. All right, let's look at this one. It says find the expression for the velocity of an object under the influence of gravity if v is equal to v naught when t is equal to 1. Okay. All right, so we've got the object is under the influence of gravity, so that tells us that the acceleration is negative 32 feet per second squared. Remember, that's from up here. That's where we're getting that. So that tells us that v is the integral of negative 32 dt. And so v is equal to what? Negative 32t plus c. All right. Now, does it give us information to find c? Yes. It tells us that the velocity is equal to v naught when the time is 0. So that tells me v of 0 is negative 32t. Well, I'm sorry, negative 32 times 0 plus c, and that should equal this v naught right here. And so what does that give us? That tells us, well, this is 0, right? And so that just tells us that c is equal to v naught. So we get our velocity is negative 32t plus v naught. All right. So far, not too much to these problems. They're just kind of simple, straightforward problems, and actually most of them are. Okay. But these are just some basic ones that we did at first. So let's look at these next ones. It says a ball is thrown vertically from the top of a building 200 feet high and hits the ground 5 seconds later. What initial velocity was the ball given? All right, so this one's a little bit tougher. Okay, so the ball is going to be falling under the influence of gravity. So we know the acceleration is what? Negative 32. And so we can find the velocity. So the velocity is equal to the integral of negative 32 dt. So v is negative 32t plus c. All right, so they don't come out and tell us, or they don't give us any information really, or don't come out and tell us any information to find c. But we do know that when t is equal to 0, we know v is equal to v naught. That's the initial velocity, right? Okay, and you know, it goes back to this problem that we just worked here. You see this? See, at time t equals 0, that's your initial velocity. Okay, so basically what we're doing is we're reworking this part of it. No, we're working the problem just like we did this one. Okay. All right. So that tells us that v of 0 is negative 32 times 0 plus c, and that is the initial velocity. That equals v naught. So we can see c is equal to v naught, and so our velocity is equal to negative 32t plus v naught. Now, what are they wanting us to find? They're wanting to know what is the initial velocity of the ball. That's what they're wanting us to know. So we have to actually figure out what v naught is. So let's look and see if they give us any other information that would help us. Well, it says a ball is thrown vertically from the top of a building 200 feet high. All right, so what does that tell us? Well, the building's 200 feet. So would you agree that at time t equals 0, at 0 seconds, the height of the ball is 200 feet? That would be the initial height, right? So that's saying that s of 0 is equal to 200, right? Because s, the displacement, that gives us the height of the ball at any particular time, and at t equals 0, the height is 200. All right, so let's look at that. Well, in order to use this, we would need to know the displacement function, wouldn't we? Okay. So let's see. we've got S is equal to the integral negative 32t plus V0 times dt. So let's integrate this. So we get S is equal to, that would be negative 16t squared plus V0 t plus some constant c. Now, look at this. It's plus some constant c. Now, look, I use c here. So what I'm going to do is I'm going to take this c and maybe change it to d. Look, if you wanted to, you could use C1 and you could use C2. It doesn't matter. I mean, just use a different letter so you don't get it confused with this C. Okay? So I'm just saying plus some constant C, but instead of C, I'm using D because I don't want to write C again because I use C here. That's all I'm doing. So now we know that S of 0 is equal to negative 16 times 0 squared plus V0 times 0 plus D. And that should equal 200. Okay? And so this tells me that D is equal to 200 because this term and this term go to 0. And so now I have S is equal to negative 16t squared plus V0 times t plus 200. So that's my displacement function. Okay, but still we haven't found what we're looking for. We want to know what the initial velocity is. And the initial velocity when t equals 0, it's equal to V0. That's the initial velocity. So we need to figure out what V0 is. So let's go back up here and see what else they tell us. It says a ball is thrown vertically from the top of a building 200 feet high and hits the ground 5 seconds later. Okay, so what does that mean? It hits the ground 5 seconds later. So that would tell me that S of 5 is equal to 0, right? Because when t is 5 seconds, the ball hits the ground. So what would be the height of the ball? It would be 0, right? All right, so I've got this condition. So I can plug this into here. So S of 5 is equal to negative 16 times 5 squared plus V0 times 5 plus 200, and that should equal 0. And so let's see what that gives us. 25 times 16 is 400. So this right here is negative 400 plus 5 V0 plus 200 equals 0. And so this is negative 200. So 5 V0 minus 200 equals 0. So 5 V0 is equal to 200. And so that gives me V0 is equal to 40. And that's the initial, that's velocity. So that's 40 feet per second. Let's see. Yeah, because see, we're in feet and seconds. All right. And so that's what they were wanting us to find in this problem, the initial velocity. All right, moving right along. It says during the initial stage of launching a spacecraft, vertically, the acceleration A in meters per second squared of the spacecraft is A equals 6t squared. So they tell us what the acceleration is in this one. Find the height of the spacecraft 6 seconds if S is equal to 12 meters when t is equal to 0 seconds and V is equal to 16 meters per second when T is equal to 2 seconds. And when I type this up, this should be, it says find the height S of the spacecraft, and right in there between spacecraft and 6, it should be after. So find the height of the spacecraft after 6 seconds. All right, my bad. I guess I should have put a space between the 6 and the S, but I didn't. All right, so let's see. We've got the acceleration is equal to 6t squared. And let's write down some other stuff that they give us. They want to find the height of the spacecraft after 6 seconds. So that means we need to find our displacement function. We'll look at this information over here. It tells us that what? V of 2 is equal to 16. Says the velocity is 16 meters per second at time t equals 2 seconds. So V of 2 is 16. And then this tells us that S of 0, right, at t equals 0, the height is 12 meters. So there's our conditions there. That's gonna allow us to figure out what our constant is. All right, so I've got V is equal to the integral 6t squared dt. So V is equal to 2t cubed plus c. Remember, add 1 to the exponent and then multiply by the reciprocal of the new exponent. That's 3. 1/3 times 6 is 2. And so now it tells us that V of 2, I'm going to use this condition here to figure out what c is. So that's 2 times 2 cubed plus c equals 16. So this is actually what? That's 8 times 2 is 16. Now let's just write it down. 16 plus c equal 16. Okay, so this tells me that c is equal to 0. So my velocity function is equal to 2t cubed plus 0, but we won't write it. We'll leave it like this. All right. So we've got our velocity function. Now what do we need to do? Well, now we need to integrate it again to find the displacement. So I've got S is equal to the integral of 2t cubed dt. And so I get S is equal to, that's 4, and then 1/4 times 2 is 1/2 t to the 4th plus some constant c, but since I already used the c here, I'm going to put this as a d. All right. So now let's do what? Let's use our condition here. S of 0 is equal to 12, so S of 0 is 1/2 times 0 to the 4th plus d, and that should equal 12. So this tells me d is equal to 12. So our displacement function is 1/2 t to the 4th plus 12. There's your displacement function. Now what does it want to know? It wants to know the height of the spacecraft after 6 seconds. So this gives me my height. So S of 6 is equal to 1/2 times 6 to the 4th plus 12. And that is 660, and let's see, we're in meters. So 660 meters. There's your answer. All right, so a little change here. I mean, we're still doing the same types of problems, but we're going to get into electrical stuff now. I think we got like 3 examples to do here. And these are the last 3 examples. So it says the current I in an electric circuit equals the time rate of change of the charge Q in coulombs that passes a given point in the circuit. Okay, so the current is the time rate of change of the charge. So that means the current would be the derivative of the charge. So I is equal to dq dt. So if we integrate both sides, we would have q is equal to the antiderivative of I dt, or the integral I dt. Okay? And then it says the voltage V of C, V sub C, across a capacitor with capacitance C is given by V of C, V sub C is equal to Q over C. All right, so VC, V sub C is the charge, the charge over the capacitance. All right, so VC is equal to what? 1 over the capacitance times what? So remember, this part right here can also be written as 1 over C times Q, right? And what is Q? Q is this. So that's where that comes from. That's replacing this Q right here. All right, so that gives you the voltage across a capacitor. And V sub C is measured in volts, C in farads, I in amperes, and T in seconds. Okay. All right. So let's work some of these problems. All right. It says the current in a certain electric circuit as a function of time is given by, and that tells us that I is equal to 6t squared plus 4. Find an expression for the amount of charge Q that passes a point in the circuit as a function of time, assuming that Q equals 0 when T equals 0, and determine the total charge that passes the point in 2 seconds. All right, so we've got to figure out what Q is, right? That's what we've got to figure out, Q. Well, do we know how to do that? Yes, we've got I, right? See that? We've got I, which is the current. So if we have I, well, Q is just the antiderivative of I. So we've got Q is equal to the integral 6t squared plus 4 times dt. So Q is equal to, that's going to be t cubed, 6 times 1/3 is 2, plus 4t, plus some constant c. All right. And so we need to figure out what c is. Well, we have this, that Q is equal to 0 when T equals 0, so that actually tells us that Q of 0 is equal to 0, right? So Q of 0 is 2 times 0 cubed plus 4 times 0 plus C, and that equals 0. Well, that's 0, so that tells us that C is equal to 0. So we get Q is equal to 2t cubed plus 4t. All right. So what do they want us to find? Determine the total charge that passes the point in 2 seconds. All right, so Q of 2 is equal to 2 times 2 cubed plus 4 times 2. And that gives us, let's see, that's going to be 16 plus 8, which is 24. And that would be what? 24C. Now, the one thing that you want to note here, this is your answer right here, but this C right here does not represent this C. It's not the C for capacitance. what did we find? We found Q. Q is the charge, and that C represents coulombs. So that's 24 coulombs. That's this. Okay? So don't get that C confused with the one for capacitance. All right, so let's look at the next one. It says the voltage across a 5.0 microfarad capacitor is 0. What is the voltage after 20 ms? So 20 milliseconds if current of 75 milliamps charges the capacitor. All right, so let's take a look at how we have to do this. Now, we may need to go back up and look at a few things because they're giving us some stuff that we didn't see earlier, that MA and that the microfarad. So let's look at this. Let's go back up here. It says we're in farads and we're in amps. So it looks like what we're going to need to do in this problem is we're going to need to convert this to farads and convert this to amps. Okay. All right, so let's see how we're going to do that. All right, so I is equal to, that's 75 milliamps. So I need to convert that. So that's going to be 0.001 times 75, which that is going to be 0.075. And that is going to equal, now what I'm going to do here is I'm going to write this in scientific notation. And that's going to be to the -2 because I'm going to move it 1, 2 places. And then the voltage, the farads, that's going to be what? And I think, let's see, 1, 2, 3, 4, 5 zeros times the 5 here, and that's going to equal point. And if I convert that to scientific notation, that's 5 times 10 to the -6. This would be farads, and this would be amps. All right, so that's the units we need to be in. So just remember, you may have to do some converting. Okay, so and I'll say this right now. I mean, I'm not going to be able to get into depth into a real detail about all this electrical stuff. I've never had an electrical engineering class, so, but I can work the problems. But this, as far as all that other stuff, your electrical engineering teacher can explain all that to you. All right, so what are they wanting us to find? It says, what is the voltage? Okay, what is the voltage? So what's voltage up here? There it is, that VC. Okay, so I thought I had written something. Yeah, it says the voltage VC across a capacitor is capacitance with capacitance C is given by this. So this is what we're looking for. This is your voltage VC. So that's 1 over C times the integral I dt. All right. So the voltage VC is going to be 1 over 5 times 10 to the -6 times the integral of I. So that's 7.5 times 10 to the negative 2 dt. And I know that looks kind of weird, doesn't it? But I mean, it's just a constant. It's a number. Okay, it's a number. That's all it is. It's in scientific notation. All right, and we could actually, and this is a C right here, and we could actually make our life a little easier by bringing this constant term out. So let's just go through the steps here. That's 7.5 times 10 to the negative 2 over 5 times 10 to the negative 6 dt. And look at this. What's 7.5 divided by 5? That's 1.5. That's this right here. And then this one, see, if you've got 10 to the negative 2 over 10 to the negative 6, that's actually 1 over, well, no, not 1 over. That's not how we want to write it. That's 10 to the negative 2 over 10 to the negative 6, which is 10 to the negative 2 minus, right, subtract exponents. And so that's 10 to the 4th. So that's times 10 to the 4th, and that's times the integral dt. Okay, so just made it a little nicer. Okay, and if you want, you can put it in parentheses to let yourself know, remind yourself that that's just one term. And so we got VC is equal to 1.5 times 10 to the 4th times T plus C. Okay. Now that's plus our constant C. All right, so but we need something to figure out what C is, don't we? Well, let's see. It says the voltage across a 5 microfarad capacitor is 0. So the voltage across the capacitor is 0. So that means that what? V of VC of 0 is equal to 0. At time t equals 0, the voltage is 0. And so I've got V sub C of 0 is equal to 1.5 times 10 to the 4th times 0 plus C equals 0. So this actually tells me C is 0. And so V sub C is just equal to 1.5 times 10 to the 4th times T. All right, so what is it wanting us to find? What is the voltage after 20 milliseconds? All right, so look at this. That they want to know the voltage after 20 milliseconds. So let me ask you this. Does it mean this? And then I would plug the 20 in for T. Is that what that means? Let's see. Let's check it out and see. Well, this right here, see what we read with the volts here? Notice what it says. T is in seconds. So we need to convert it, don't we? And so that would be what? 20 times what? Times point. Now, how do I go from milliseconds to seconds? Well, I multiply it times 0.001, which that is going to give me 0.02. So no, I don't use 20. I use 0.02 equals 1.5 times 10 to the 4th times 0.02, and that is actually comes out to be 300, and that would be 300 what? 300 volts. And that's your answer right there. Okay. Last problem. It says a certain capacitor is measured to have a voltage of 100 volts across it. At this instant, a current as a function of time is given by, okay, so I is equal to 0.06 square root of t is sent through the circuit. After 0.25 seconds, the voltage is measured to be 140 volts. What is the capacitance of the capacitor? All right, so we've got information. They give us I. We got information dealing with volts. They want to know the capacitance of the capacitor. And so that tells us that VC is 1 over C. Okay, that's C, that's for the capacitance, times the integral of 0.06 square root of t dt. And I'm going to go ahead and write this a little bit different to make it a little easier on ourselves. So VC is 0.06 over C times the integral t to the 1/2 dt. I just changed that square root to an exponent. And so what do we do now? Well, now we can go ahead and integrate. So I've got VC is 0.06 over C, and that's going to be t to the 3/2, so times the reciprocal 2/3 plus C. Now remember, this C and this C are not the same. I'll try to keep making this one bigger. Okay, and I tell you what, let's just call that C1 so we don't get them confused. Okay, and so this tells me that VC is equal to, this will end up being 0.04 over C t to the 3/2 plus C1. All right. So somehow we need to figure out what C1 is, don't we? Let's see. It says a certain capacitor is measured to have a voltage of 100 volts across it. All right, so that tells me that V of 0 is equal to 100. Okay, so our V sub C of 0. And so V sub C of 0 is 0.04 over C t to the 3/2 plus C1 is equal to 100. Whoop, I'm sorry. Let me change that t to a 0. That wouldn't be good, would it? So I've got C1 is equal to 100. So that tells me V sub C is equal to 0.04 over C times t to the 3/2 plus 100. All right, so what are we looking for? We're looking for C, right? The capacitance. That's what they're wanting to know. What is the capacitance of the capacitor? So we need to know what C is. So we still got this variable here. We need to figure out some way to solve for it. So let's see what it tells us. It says after 0.25 seconds, the voltage is measured to be 140 volts after 0.25 seconds. So that actually tells me that V sub C of 0.25 is equal to, I think it was 140? Yeah, 140. Okay. And so now that tells me V sub C of 0.25 is equal to 0.04 over C times 0.25 plus 100 is equal to 140. And now what do I have to do? I have to solve that equation for C. And that actually gives me C is equal to, and if we put it in scientific notation, that's 1.25 times 10 to the -4 farads. Okay, so remember when you saw it, remember from earlier, that's in farads. And so that's that in farads. And you know, if you wanted a little bit nicer number, you put 125 microfarads. You can convert this farad to microfarads. So I don't think they told us what unit to put it in. And you know, like I said, I don't know in electrical engineering. I don't know if they always give it to you in microfarads and you have to convert to farads. But you know, anyway, there it is. That's how you would work that problem. And that's it. That's all of this video. So I hope this helped. Hope you learned something. Check out my other videos. Give me a like, share, and subscribe. Thanks for watching, and I'll see you in the next.